morning, chemistry. I am going to go over some of the problems from the Unit 7, Section C, the one that had the molarity problems on it. Now, I don't have the sheet printed, but hopefully you do. So I can read the problems off my computer, but I can't show you the sheet. So you should have the sheet with you, or at least be able to follow what I'm doing. Okay, so I'm only going to go over the first sheet because I've noticed that a lot of people who are turned it in, and some of you haven't turned it in yet, but a lot of people who have turned it in are having problems with it. And I want to go over the first sheet and then let you go back and see if you can get through the second one on your own. And then we can look at it. Okay, so this is only the first problem set. It says Unit 7C Molarity Practice Problems 1 at the top. Okay, so let's go through them. You have the first problem is to make a 4 molar solution. How many moles of solute would be needed if 12 liters of solution are required? Okay, so I have the equation set up right here, and the equation is for molarity, the moles of solute over the liters of solution. Now you want to make sure that you have the units correct. Some of these have you making conversions, so be really careful with that. All right, so the first one, we want to figure out what we need here for 4 moles, or the 4 molar solution. Okay, so you're just going to put this in here. This is your unknown, how many moles of solute. So we're just going to take the formula and just plug it in and plug in what we have. So we have the molarity, we have the amount of solution, and we're just going to multiply both sides by 12 and cross that out. So then you have 12 times 4, okay, because you're multiplying both sides by 12, and you're going to end up with 48 moles of solute. Okay. Now, on number 2, we have the problem says how many moles of sucrose are dissolved in 250 milliliters of solution if the solution concentration is 0.15 molarity. Okay, so we are going to go back right here. The first thing you have to do is convert 250 milliliters to liters. So that's going to be 0.25 liters. All right, and you want to know how many moles of sucrose. You don't have to know the molar mass of sucrose or even the formula, because you're just looking at moles and you're not converting anything with grams, so you don't have to do that. All right, so you have, similar to what we just did, you have 0.15 molar or molarity, and then you want to know the moles of sucrose with a 0.25 liter solution. So you're going to do the same thing you did up in number 1. We're multiplying both sides by 0.25 to get rid of the fraction. And we're going to multiply 0.25 over here. I don't know if you can see that. And you're going to get 0.0375 moles of sucrose. Okay. Now, number 3, it's a little different because you have to convert grams to moles. Okay, so let's look at the problem. Says, what is the molarity of a solution of HNO3 that contains 12.6 grams of HNO3 in 1 liter of solution? Okay, so the first thing we have to do is convert grams to moles for HNO3. So we want to find the molar mass of HNO3. So I've written that out here. We know that the molar mass of hydrogen is 1, nitrogen is 14, and oxygen is 16. Okay, and that is the same thing as your atomic mass on your on the periodic table. Okay, so you have the atomic mass right here. That's how you find the molar mass. Okay, so I found out that I have 63 grams in 1 mole of HNO3. Okay, so 1 mole of HNO3 is equal to 63 grams. Now, I want to find out, I have 12 point, let me look at my sheet. I have, what is the molarity of a solution of HNO3 that contains 12.6 grams? Okay, I just forgot what I was doing. Sorry about that. Let me get my telemarketer hung up. Okay. So we are looking at 12.6. We know that 63 grams are in 1 mole. So we're going to divide that and get 0.2 moles. So 12.6 grams is equal to 0.2 moles. Okay. So I want to find out what the molarity of the solution when you have 12.6 grams in a 1 liter solution. All right, so I'm going to plug this in and I'm just going to calculate the regular molarity, not going to move anything around. I've got 0.2 moles of HNO3, which is the same as 12.6 grams, over 1 liter solution. And so that gives me 0.2 molar solution of HNO3. And I put this here because it's not obvious how you say it. So I just wanted to give you guys a note on that. It's 0.2 molar solution of the chemical. Okay, so it's 0.2 molar solution of HNO3. Just to give you a pointer on that. Okay, now number 4, let me pull it down. Okay, the question for number 4 is how many grams of potassium nitrate are required to prepare 0.250 liters of a 0.7 molar solution of potassium nitrate. Okay, so this one's a little long, so just stay with me. I have a 0.7 molar solution, and I want to know how many grams are required for a 0.25 liter solution. So the first thing you notice is that it says grams instead of moles. Okay, so we got to figure out what that is. Okay, so you have, we're going to just set it up like this. Okay, solving for how many moles. So we're going to get rid of our fraction by multiplying both sides by 0.250. Okay, so 0.250 is 1.75. Then you're dividing both sides by 0.250 to get the moles. So you're going to end up with 7 moles of potassium nitrate. Now, potassium nitrate is KNO3, and how did I know that? Well, KNO3, or potassium nitrate, is an ionic solution or ionic molecule. So if I'm looking at the table of ions, Potassium is a cation with a charge of 1 up here. This is potassium. Then you're looking for nitrate. That's down here, and it also has a negative 1 minus, so that's NO3. So there's no crisscrossing because both of them have the same charge. So that's how we have potassium nitrate is KNO3. Okay, now we have to convert to moles. We have to convert to grams, sorry. I'm not looking at the sheet. How many grams of potassium nitrate? Okay, so we know how many moles, we just have to find how many grams, and that's where we start doing our conversion. Okay, so you have 7 moles, and you've got to convert that to grams. So we're going to do our conversion factor here. 7 moles is, your conversion factor is 1 mole of KNO3 is 101 grams. And I figured that out down here because K, potassium, has 39, the mass is 39, or number of grams, I'm sorry. Nitrogen is 14, oxygen is 16. There's 3 oxygens, so that's 48. So to find out how many grams are in 1 mole, you've got 101 grams in 1 mole of KNO3. Okay? So with that, with all these calculations, because I put the 101 up here, so I've got moles and then 1 mole to how many grams are in 1 mole. That's your conversion factor. You're going to multiply everything across. You're going to get 707 grams. Okay, and it's asking for how many grams of potassium nitrate. Okay, so that's your answer, 707 grams of KNO3. Okay, that one's kind of long, but you can do it. All right, on number 5, the question is 125 cubic centimeters of solution contains 3.5 moles of solute. What's the molarity? Okay, this one was tricky, and you have to convert cubic centimeters to a liter, okay, because you want to know the cubic centimeters of solution, and you have to convert that to liters of solution. Okay, so I looked it up. So you'll have to look things like this up, and I won't do this to you on a test. But I looked up that 1 liter is 1,000 cubic centimeters. Okay, and that's just, I Googled it because that's not something I expect y'all to know. All right, so I have, it has you have 125 cubic centimeters. So because 1,000 cubic centimeters is equal to 1 liter, you're going to, make sure I can see it, you're going to take 125 divided by 1,000. So you have 0.125 liters. Okay? Now you can figure out your molarity. So you have 3.5 moles over 0.125 liters. And that's going to give you a 28 molar solution. Okay? So you didn't have to really know even what the solution was, but this is just converting cubic centimeters to liters, which I promise I will not do to you. Okay? Now, number 6 says, which solution is more concentrated? Solution A contains 50 grams of CaCO3, excuse me, in 500 milliliters of solution. Solution B contains 6 moles of H2SO4 in 4 liters of solution. So we want to know which one's more concentrated. And the way you know which one's more concentrated is the number for the molarity is higher. Okay, so that's how you know that. All right, so let's look at this. We're going to set it up. We have 50 grams of CaCO3, and we have to convert that to moles. And this is the same way we did it before. You're taking the atomic mass times how many of each element you have. So you're going to end up with 100 grams of CaCO3 is in 1 mole. So 1 mole is equal to 100 grams. Now we're going to figure out the molarity of A. You have, I'm sorry, I left this out. You have to know how many 50 grams is 0.5 moles. Yeah, so it's 50 grams. I'm sorry, I'm looking back at my sheet. You have 1 mole is 100 grams, but it wants to know how much 50 grams is. So that's half a mole. That's 0.5 mole. Now we're going to plug it in. You also had to convert milliliters to liters. So that's our conversion for that. So you're going to end up with 0.5 moles over 0.5 liters. Okay, so a number over itself is what? 1. So solution A is 1 molar solution of CaCO3. Okay, so your molarity is 1. Okay, now B, yeah, we got 2 parts. You have, it says that you have 6 moles of H2SO4 in 4 liters of solution. Okay, so this one you're just calculating it. It's a lot easier than the first one. 6 moles over 4 liters, and it's 1.5 molar solution of H2SO4. Now, to find out which one is the more concentrated, you're looking at the number of the molarity. So 1.5 molarity is more concentrated than 1 molar. Okay, so solution B is your answer. Okay, now number 7 is how many liters of solution can be produced from 2.5 moles of solute if you have a 2.0 molar solution. Okay, so you have a 2 molar solution and you have 2.5 moles and you want to know how many liters can be produced. Okay, so this one's kind of weird. You know, if you can do it a different way than I'm doing these, that's perfectly fine. But I'm just plugging everything in and then solving. So my variable is liters because I don't know how many liters I have. I'm multiplying on both sides. You're going to end up with 2 times every how many liters equals 2.5. Then you're dividing both sides by 2 to get rid of this 2. You're going to end up with 1.25 liters. Okay, so that one's just going to get you on the algebra because it's pretty straightforward. Okay, now number 8, last one. We have what would be the concentration of a solution formed with 1 gram of NaCl and it's dissolved in water to make 100 milliliters of solution. Okay, so on this one, you have grams and you have milliliters, so you've got to take care of those. So 1 gram of NaCl is you're looking at what the molar mass of NaCl is, and I've written that out for you. The molar mass is 58.5 grams. So 1 mole of NaCl is equal to 58.5 grams. Then you have to find out 1 gram is how many moles. So we're going to divide that and find out that 1 gram is 0.017 moles of NaCl. Okay, when you're doing these calculations to try to find things like this, make sure that you've got the right thing on each side. And the way that I do it to make sure I'm not making a mistake is I only have 1 gram of NaCl and 1 mole is 58.5. So I know that my number is going to be less than 1. Okay, so if it's more than 1, you've got a problem. So make sure you double check these. All right, so 1 gram of NaCl is 0.017 moles. I'm converting my milliliters. 100 milliliters is 0.1 liter. So then I'm just going to plug everything in to find the molarity. 0.017 moles over 0.1 liters, and that's 0.17 molar solution of NaCl. Okay, now I'm going to let you guys do the second problem set yourselves. If you've already done it, go back through it and make sure that you look at this for an example of how to do it. I'm seeing a lot of people are confused with that, so I'm going to give you guys a chance to go through the second set yourselves. And then send me questions on Remind so that I can help you with it. But then I want you to try those, and then we can go over the other set tomorrow afternoon. Okay? So we want to make sure that you guys can do these. I'm going to try to not make the ones on the test too complicated, but you do need to be able to plug this in. Okay, you got to be able to do molar mass and be able to convert liters, milliliters to liters, grams to moles, things like that. Normal stuff that you should be able to do. Okay, so I'm going to let you guys go. Send me messages on Remind if you need help. Otherwise, I will get the other video up tomorrow. Go ahead and put in homework drop, your second sheet again if you want to correct it. And let me look at those before I do the video so I can help you with any problems you're having. Okay, so we will talk later. Bye.